Hi everyone, so this is the video explanations for experiment 3 entitled as thermal and electrical conductivity of metal, where in this particular experiment you will use two types of metal, the aluminium and the copper. Now before we start with our procedure, I need to explain a few things for this experiment and also the objective of this experiment. So there are three main objectives of this experiment. For the first and second objective, it will be divided into two parts, part A and part B. And then the third is the combinations between first and the second objective, which is to test the Whitman-Franz law L. Now, this is a few things for this experiment. You have your calorimeter here. There are two types of calorimeter in this experiment. You have your lower calorimeter, and then one on the other side is upper calorimeter. So what is the difference between this upper and lower calorimeter? Your upper calorimeter have a hole at the bottom of the calorimeter. Meanwhile, your lower calorimeter doesn't have any. And then you have your temperature meter here. This is your digital temperature meter. Bear in mind that in this experiment, you will not use any manual thermometer, but instead you will use this one. So in this temperature meter, you have two types of rod, the white one and then the black one. So what is the difference between this black and white one? This black can be put inside your water, but differently with this white, it cannot be touched or sink into any water. So be careful on that one. And then to use this thermometer, you have to set the light of this color, this rod, match with the positions of the rod. So let's say I need to read the temperature of this room right now. It's supposed to be read with 23.8 because the red light is on the upper display. Now, how to set up this one? Just push on this button. Where the button set T1 to 4, it's supposed to be move the red light until where the rod I need to use. There are two types of unit for this temperature, degree Celsius and Kelvin. If you wish to use the degree Celsius or you wish to use the Kelvin, just push to this button and it will change automatically. You also provided with beaker here for the first objective, and then you have your weight scale, and you also have this setup here where this is for the second part of the second objective. Now in this setup you are provided with multimeter, two multimeters. You have your power supply here at the bottom and then amplifier at the top, and then this is your rheostat where you can adjust the resistance. So for the first part of the objective 1, which is to determine the heat capacity of calorimeter, you will need this lower calorimeter here with the lid, your weight scale and also the temperature rod. Now this temperature meter is already set into degree Celsius for your readings. Now as for the tables, you can refer with your book, your manual book on page 93. So you will need to weight this calorimeter without the lid and record the mass of empty calorimeter. And then after that, you are usually provided with preheated water by your lab assistants. If you need to reheat it again, it's up to you. So before start to fill in the calorimeter with hot water, please make sure to record the room temperature and then the temperature, the initial temperature of this calorimeter without any water. And then fill in your calorimeter with preheated water, close it and re-wet it again. After that, read the mixing temperature inside this calorimeter and record all the provided data in your book in page 93 for the first part of this objective 1. Now, for the second part of objective 1, which is to determine the influence of surrounding heat on calefaction of water, 0 degrees Celsius without pieces of ice, delta Q, you will need these materials. Now, fill in your jug with a amount of water, and then put provided ice to you. Put ice into it, and stir until the water temperature becomes 0 degrees Celsius or lowest possible. So it is very possible. It is very impossible to get 0 degrees in this experiment, but then try to get a single number of lowest temperature, which is below than 10. After you get the lowest possible of the temperature, take out the ice, if there is any left, and then pour this water here with the lowest temperature into the calorimeter. Close the calorimeter, and then start your reading and record the temperature change for every 1 minute for 30 minutes. You can feel the result of this part of the experiment into the table in the page 93. Now, for the first part of objective 2, which is the objective is to measure the calefactions of cold water as a function of time and determine the thermal conductivity of the metal rod, you will need this setup. Now, it will involve the upper and lower calorimeter and also the temperature meter here. You also need 2 types of metal for this experiment. As for this video, I will only use the aluminium. So after you done with the first procedure for the aluminium, please repeat it again with copper. Now, before start, you have to weight this empty calorimeter both at the upper and the bottom of the calorimeter before you sit. And then you have to fill this upper calorimeter with hot water. I will recommend a very hot water, so you have to reheat your water before pour it into your upper calorimeter. And then this lower calorimeter, fill it with tap water or cold water, and make sure to set this temperature rod with to display this temperature rod for change of temperature. How to use this? You have to push this button with the symbol of delta T here. So this reading right now will show the temperature difference between this point to this point. And then the upper display will be the reading of the temperature in the lower calorimeter. So you can dig this into the lower calorimeter. So after fill this one with the hot water and fill this one with the cold water, you have to make sure the reading on the lower display is constant. Now, how to do that? You have to put inside a pouch of ice and make sure that you have a constant reading here before take out this ice. So after you get a constant temperature here, take out this ice here, if there is any left, and then record the change of differential temperature, which is the lower display, and the water in lower calorimeter, which is on the upper display, for 5-minute periods for every 30 seconds. Now, all this data can be recorded and write it into the table provided for you in page 94. Now, for the second part of objective 2, which is to measure the electrical conductivity of metal with variable resistance, you will need this setup. So in this setup, you are provided with measuring amplifier and also power supply. Both of this measuring is already set by your lab assistant. So please do not change anything. And then you also provided with 2 multimeter, which one of the multimeter will be set for ammeter to read your current, and also the other one will be set to voltage to read your voltmeter to read your voltage. You also provided with this rheostat with the unknown resistor. Now, to use this, set your rheostat at the maximum resistance, which is this is the point of the maximum. with the unknown resistance, and then move it to the next stop, which the next stop should be constant with the next stop. And when you stop here, make sure to get the reading of the current and also the voltage here, and record it into the table on page 94. Now, try to get about 5 to 6 reading or 5 to 6 constant stop for this part of the experiment. So you have done the experiment 3, now it comes to your calculations. Now, these calculations also divided into 5 parts according to your objective. So, for the first objective, part A, you need this type of formula. So, this formula is quite familiar with you because you already seen it on last semester, where C is equal to the heat capacity of calorimeter, which the unknown that you should determine. And then CW is the heat capacity of water, which the constant value is equal to 4.187 joule per gram Kelvin. MW is the mass of the water. Theta W is the temperature of the water. And then theta M, this one is the temperature of the hot water that you use in your experiment. And then theta M is the temperature of the mixture water when the preheated water put inside your calorimeter. This theta M here is equal to, it's the same value with this one, and theta R is the room temperature in Kelvin. Now, suppose when you substitute everything here in this formula, you will get the value of heat capacity of calorimeter equal to 66 plus minus 1 joule per gram Kelvin. For the part B of objective 1, you will have this table where the reading of temperature in Kelvin was recorded by you for about 30 minutes, and the delta T can be measured by subtracting the value of T on the particular minutes with T equal to 0 minute. And delta Q can be calculated using this formula, which delta Q is equal to CW. CW is the heat capacity of water, 4.187. MW is the mass of the water, and C is the heat capacity of calorimeter, which you get from your first objective. If you get your C not equal to 66, you have to use that one. And delta T is equal to delta T in your table. Now, from this table, you also need to plot a graph, which I call it as graph 1 and graph 2. So your graph 1 is supposed to be temperature versus with the time in minute, and your graph 2 is equal is for the heat versus with the time. Now, for the graph 2, you have to determine the gradient. This is the gradient of this graph, and this gradient is equal to, the value of this gradient is equal to the dq over dt for the ambient. That was for the second part of the first objective. Now, for the second objective, on part A, you will get this table where you are recording the reading of the temperature and the delta T of the metal for about 5 minutes, which is 300 seconds. And you also need to calculate the delta Q. So the delta Q here, the formula is similar on the upper part. And then from this table, you also need to plot another 2 graphs. I call it as the graph 3 and graph 4. Now your graph 3 is supposed to be get a gradient from graph 3, where this gradient is equal to delta T over delta time. And your graph 4 also, which is the plot between your Q and time in second, you also get a gradient, which this gradient is the value of dq over dt for ambient plus metal. Now, for the part B of second objective, the main objective is to find or to calculate the conductivity of the rod. Now, for this one, the symbol of this conductivity of metal is symbolized as your wavelength. So to find this wavelength, you're gonna need to use this formula. So this formula is complete by dq over dt, which this dq over dt is equal to dq over dt for the metal, the area which given to you in this slide, and then delta T over delta T, which is the gradient of temperature over time. So to find the dq over dt for the metal, you're gonna need to use this formula. So to use this formula, I have to subtract the dq over dt for the metal plus with the ambient with the dq over dt of the ambient. So where do I need to find this dq over dt for metal plus ambient? You should get it from the gradient of graph 4 just now. Now for the part B of objective 2, which the aim is to calculate the conductivity of the rod, which the symbol for this conductivity of the rod is this lambda. To find this lambda, you have to use this formula. Now this formula is complete by these symbols, which is dq over dt for the metal, and then A is the area, which the area of the metal for both copper and aluminium is equal to 4.91 to the power of negative 4 meters squared, and this delta T over delta T, which this T is this is the gradient of temperature and the time. So to find the dq over dt for the metal, you have to use another formula, which is this formula is actually just subtractions between the gradient of the graph 4 and the gradient of the graph 2. So the gradient of the graph 4 will represent the dq over dt for the metal plus with the ambient. Ambient is the surrounding, and dq over dt and the gradient on the graph 2 is represent the dq over dt for the metal. So when you subtract two of this value for the gradient, you will get the dq over dt for the metal. So this one will be complete. And then as for this one, which is the delta T over delta T, the temperature and time, you will get the value from the gradient of graph 3. So by substituting everything and rearranging to find the lambda, you will get the lambda, which is the conductivity of the metal, which you will use it again at the objective 3. This is the last part of these calculations. So if you still remember, you have to record the value of voltage and current to determine the resistance. Now, from this table 4, which I call it as a table 4, you have to plot another graph, which is the graph 5. From the graph 5, you will get, or you need to find the gradient, which the value of the gradient is supposed to be equal with the resistance. Now, this value of resistance, you have to use this value of resistance to find the electrical conductivity of the metal. So to find the electrical conductivity of the metal, you have to use this formula, which is, it is symbolized as the alpha. Alpha is equal to length over area times with the resistance. So length and the area is similar with earliest data that I've given to you, and this resistance is from the gradient here. So by substituting everything, you will get the value of electrical conductivity. Now to end these calculations, which is the last objective, you have to prove the Widman-Franz law. So the Widman-Franz law is written as this formula, where L is the Widman, lambda is the conductivity of the rod, and alpha is the electrical conductivity of the rod, and T is the room temperature in Kelvin. So you already get this value from the part B of second objective, and this is from the first part of this objective 3. Temperature is in Kelvin. You're supposed to get the L value, which this L value will be compared with this value is equal to 2.4 to the power of negative 8 watt ohm per Kelvin square. That's all for this experiment.